will now pass on to problem number 8. If the heights of 500 students are normally distributed with mean 68.0 inches and standard deviation 3.0 inches, how many students have height A subdivision greater than 72 inches, B less than or equal to 64 inches, and C between 65 and 71 inches? Now let us see what are all the data given in the problem. Given that mean is 68, so that is mu. So given that mu is equal to 68 and standard deviation is 3, that is sigma. So sigma is equal to 3. Now the first subdivision, we have to find how many students have height greater than 72 inches. First let us find the probability for one student whose height will be greater than 72 inches. And once we get the probability for one student having height greater than 72 inches, we have to multiply it for, out of 500 students, we have to multiply it by 500 to get the number of students whose height is greater than 72 inches. Okay, so we have to find P of x greater than 72. Remember, the standard normal variate is nothing but Z is equal to x minus mu by sigma. So we have to find what is Z when x is 72. Once we find Z, only then we can refer to the table where the values are given for the standard normal variate, which is Z. So let us calculate Z, which is equal to x minus mu by sigma. So x is now 72. So Z is equal to 72 minus your mu is 68 divided by 3. And 72 minus 68 is 4. So 4 by 3, which is 1.333. Goes on and on. We will round it to 2 decimals, which is 1.33. So now P of x greater than 72 is equal to P of Z. I am converting x to Z. So P of Z greater than, we have found the corresponding value as 1.33. So what do you mean by Z greater than 1.33? We know that the normal curve is a bell-shaped curve. So look at this diagram. So from minus infinity to plus infinity, the total area is 1. And we know it is symmetric about the mean. That is here Z is equal to 0, which is x is equal to mu. So at x is equal to mu, the area is divided to the right from 0 to infinity as 0.5 and the area to the left from minus infinity to 0 as 0.5. So we know that the area from 0 to infinity is 0.5. But we want the area greater than 1.33, which is the shaded area. So Z greater than 1.33 is this part. So from 0 to infinity, we know it is 0.5. So from 0.5, if I subtract this area from 0 to 1.33, this area if I subtract, I will get the shaded area. So Z greater than 1.33 is nothing but total area, which is 0.5, minus the area under Z is equal to 1.33. Now when you refer your book, page 230, you can take your book, your textbook, page 230. Look at the tabular column. For 1.33, Z, the last column, it is 1.33. So under 1.33, if you see the value is 0.4032, are able to identify 0.4032. So 1.3, the value is 0.4032. So I'll substitute that value, 0.4082. 4082, not 32, 4082. So when you subtract from 0.5, you know 0.5 is nothing but 5, and then you can put 3 zeros and you have to subtract 4082. So it is 10 minus 2, 8, 9 minus 8, 1, 9 minus 0, 9, and 4 minus 4, 0. So it will be 0.0918. Is that okay? So this is the value for the probability of x greater than 0.7, for probability of x greater than 72. This is 0.0918. This is for one student. So now therefore out of 500 students, because the question is to find out of number of 500 students, how many students will have height greater than 72? So out of 500 students, number of students whose height is greater than 72 inches is equal to, so it is 0.0918 into 500. Okay, this is for one student. So we are now finding it for 500 students. So when you multiply with the 500, first we will multiply with 5. 5 8s are 40, carry 4. 5 1s are 5 plus 4, 9. 5 9s are 45, carry 4. 5 zeros are 0 plus 4 will be 4. And then 2 zeros. And how many places? 1, 2, 3, 4 decimal places. Naturally, these 3 zeros will have no value. And it is equal to 45.9. But we are here referring about the number of students. Can you say there are 45.9 students in your class? No, it has to be rounded to the nearest integer. So it is 46. So the number of students out of 500 whose height is greater than 72 inches will be 46. Now let's pass on to the B subdivision, which is less than or equal to 64 inches. So it is P of X less than or equal to 64, which is asked. P of X less than or equal to 64 inches. So as in the previous case, we have to calculate what is Z when X is equal to 64. So how will you calculate? Z is equal to, therefore, X minus mu. So X is what? 64 minus your mu is 68 by sigma, which is 3. 64 minus 68 will be minus 4 by 3, which is equal to minus 1.33. Here it is minus 1.33. So now we have to see where will minus 1.33 lie. As in the previous case, we had 1.33 to the right. Now consider the normal curve where you have plus infinity to the right and then minus infinity here to the left, and 0, this is here in the middle. Now minus 1.33, so it will be to the left, negative side. So this is your minus 1.33. Is that okay? Now we want P of X less than or equal to 64. P of X less than or equal to 64, which is equal to P of Z, which is now less than minus 1.33. Is that okay? So less than means what? To the left. So this is the shaded area which we want now, less than minus 1.33. So now again we know that the area from minus infinity to 0 is 0.5. So from 0.5, if I subtract this area from 0 to minus 1.33, we will get the required area, that is the shaded area. Is it okay? So which is 0.5 minus P of minus 1.33 less than Z less than 0. So from the total area 0.5, we subtract this part. The unshaded area is to be subtracted to get the shaded area which is wanted. So 0.5 minus P of minus 1.33 less than Z less than 0. But minus 1.33 to 0 or 0 to 1.33, the area, it is by symmetry the same. Because you know that the curve is symmetric about the mean. So this is nothing but from 0 to plus 1.33. So only for the previous subdivision we refer to the table and we saw the area under 1.33 was 0.4082. Okay, so we can substitute the same value. So 0.5 minus 0.4082. So if you subtract, you will get the same value. Last case we have subtracted here 0.0918. Is that okay? Now P of X less than or equal to 64 is 0.0918. So now this is for one student. Now let us calculate for 500 students. So therefore out of 500 students, number of students whose height is less than or equal to 64 inches is equal to 0.0918 into 500. Is it okay? So what will that be? The same value which we got last case. So that is equal to 500 into 0.0918, which is equal to 45.9. Again, it is rounded to 46. So the number of students whose height is less than or equal to 64 inches is also the same, which is 46 students. Now let's pass on to the C subdivision. What is the C subdivision? In the previous, between. So number of students whose height is between 65 and 71 inches. So which means, so between 65 and 71 inches. This is what is asked. So that is P of 65 less than X less than X less than 71. This is what is to be found. So we have to calculate now when X is equal to 65, what is Z? And when X is equal to 71, what is Z? Both we have to find. So let us do that. So when X is equal to 65, Z is equal to, what is Z? X minus mu by sigma. So 65 minus, you know what is your mu? The given data is 68 and sigma is 3. So 65 minus 68 by 3, which is minus 3 by 3, which is minus 1. So when X is equal to 65, your Z value is minus 1. Next, when X is equal to 71. So what is Z again? We have to use the same formula, X minus mu. So X is 71 minus mu is 68 by 3. So 71 minus 68 is what? 3. So 3 by 3, which is equal to 1. So we have got the corresponding Z values for both X equal to 65 and 71. So we can now write the data for Z. So probability of 65 less than X less than 71 is nothing but P of, what is the value for Z when X equal to 65? It is minus 1 less than, now X is now converted to Z, less than, what is the value of Z when X equal to 71? We have calculated it as 1. Is it okay? So it is minus 1 to 1. Now we have to calculate the probability. So again, let's see the diagram. So this is your bell-shaped curve. This is your Z is equal to 0. And then, so from, I want the area from minus 1, which will be in the left of Z equal to 0, and 1 will be to the right. So now we want the area from minus 1 to 1. So this entire area from minus 1 to 1, which is what we need, okay, the shaded area. So what shall we do? We can now split from minus 1 to 0 and then from 0 to 1. Is that okay? So this is nothing but probability of minus 1 less than Z less than 0 plus probability of next 0 to 1. 0 less than Z less than 1. Now minus 1 to 0 is symmetric as that of 0 to 1. So for 1, once again, if you refer your tabular column in your text, you can take your book, page 230. So it is now for 1. So look at this. For 1. So it is 1.0. Are you able to see what it is? So for 1.0, that is 1, it is 0.3413. Is that okay? So 0.3413. So this is equal to 0.3413. For minus 1 to 0 also is the same as 0 to 1. And again from 0 to 1. So 0.3413. So we have to add. So what will that be? Which is equal to 3 plus 3 is 6. 1 plus 1 2. 4 plus 4 8. 6. 3 plus 3 is 6. So 0.6826. So this is for one student. Therefore, out of 500 students, so out of 500 students, number of students whose height is between 65 and 71 inches is equal to, so for one student is 0.6826. So it is 0.6826 into 500. Is it okay? So this is equal to, multiply with 5 and then add 2 zeros. So 6 5s are 30, carry 3, 6 5 2s are 10 plus 3 13, carry 1, and then 5 8s are 40, 41, carry 4, 6 5s are 30, 34. And then you have to put 2 zeros. Is that okay? And how many decimal places? 4. So 1, 2, 3, 4. So these 3 will have no value, which is 341.3. So if you round it, it is 341, approximately 341 students. So number of students out of 500 whose height will lie between 65 and 71 inches will be 341 students. Is that okay?